Okay, so I have sections 5 and 6 remaining of my lecture on magnetism. This is on polarity and incommensurability. Two, you think, very simple terms to define, but not easily. Everybody thinks they understand what polarity means, but nobody really does. You say vortex. Everybody loves to use the word vortex, too. Define a vortex. Well, it's like, no, that's a description. It's not an explanation. Anyway, I'd like to have you take a look at something here. It's using a simple program to create a hypertrochoid. In the case of centrifugal divergence or magnetism specifically, as we're referring to it since this lecture is on magnetism, we would be looking at expanding and contracting circles. Instead of drawing lines like this, which this program is limited to, and I filmed myself doing this, we're actually looking at expanding and contracting circles, specifically of force divergence as pertains to magnetism, which obviously also includes, since it must be three-dimensional by nature, but we're looking at a two-dimensional image, is expanding and contracting circles from counter space. The actual release of inertia or energy, we would have an expanding circle, just the same as an explosion is spherical in shape, if it is, in its most native and simplex form instead of like a shape charge, for example. But this pattern, of course, is repeating itself in 360 degrees, and we end up with a hypertrochoid. This is also part of the golden angle. There's a golden ratio, but there's also a golden angle, which is 137.5077, or specifically, more simplex, 138 degrees. But anyway, we're looking at that. Let's go on to the diagram here, and let's try to define things. I've actually blocked this off in blue to define the magnet, where the magnet would be in relationship to these field pressures, but obviously the red lines, which of course extend out past the image, or the magnetic torus, and the white is the dielectric increasing inertia and acceleration to a point of counter space, and yellow is the plane of inertia. Yellow, of course, would also be the disk of say a spiral galaxy. We also see this same geometry from macro to micro, and of course a native force vector, even though I can only show you on a two-dimensional screen, must be three-dimensional. So let's get to defining polarity and incommensurability, and talk about a laser analogy here in a second. But take a look at this geometry, because this is the native geometry, the conjugate magnetodielectric geometry that actually defines the universe. So, and also want to show you something really important after this in the fifth section of the sixth, and have you think about it. And magnetism and this conjugate magnetodielectric are extremely simple, but they're not simplex. Understanding and people actually having within their minds a three-dimensional understanding of what's going on, and understanding what a three-dimensional force vector looks like, which is a three-dimensional S-curve, is hard for people to visualize. So let's get on to defining polarity. Polarity is a wholly misunderstood conceptual term to refer to the release of a force from a point source. Magnetic polarity necessitates that one understand that a human line is not Mother Nature's line, from which one is a non-Cartesian nexus in counter space and is three-dimensionally curvilinear, as necessitated by geomagnetic precession, and the native force vector to be an expansive torus. Here we see the same hypertrochoid. We would actually have the centrifugal magnetism, and a darker line here at the center of the centripetal convergent. Of course, we see this also on the supercell. Polarity in simplex is nature's force vector, which is divergent from counter space and curvilinear, necessitatively so, since polarity is obviously not merely two-dimensional. People think of polarity in the case of a line. They think, well, that's nice. Here we actually have Mother Nature's line as opposed to a human line. Okay, but that's two-dimensional. Obviously, a force vector cannot be merely two-dimensional, so we have to think of a force vector divergence from a point of counter space, which is not a point in the sense that it has a Cartesian nexus or locus. But it also has to be three-dimensional, necessitatively so. When you have a three-dimensional force vector, you of course end up with the geomagnetic precession. This of course defines or outlines, if you will, the so-called vortex. Everybody loves to use the word vortex, but they don't know what they're talking about. We love vortexes. We love to talk about them. But does anybody really understand what a vortex is? Well, it's really simple, but people only ever describe it. They never define a vortex. So geomagnetic precession is the full and complete dimensional reification of polarity. By definition, as it must be three-dimensionally divergent. It's not any more complicated than that. Two-dimensional force divergence is impossible and illogical. Dimensionally, magnetism is an extrapolated vortex, given multiple divergent vectors from each so-called pole. These force divergences are tied like a dog to a stake in the ground to the plane of inertia, or the null nexus of dielectric inertia or counterspace, regardless of the name we wish to apply to it. Let's go on to, here we have the fundamental current of the red outlined, magnetic outlined in red, and the blue outlined outlining the dielectric. Here we have the conjugate geometry of force and motion, inertia and acceleration, the inverse geometry of the torus and the hyperboloid. Hyperboloid, of course, being the hourglass shape. At the center of all magnetic fields, there is no magnetism. At the center of gravity, there is no gravity. Retroductive logic necessitates that there is only one field, the dielectric, since magnetism is the dielectric field being expressed in force as implied the loss of inertia. And electricity is the construct of magnetism and dielectricity working in unison to create a self-reproducing energy construct, which, of course, propagates. Gravity is merely incoherent dielectric acceleration or point non-specific mutual mass acceleration towards counterspatial vector, as implied the smallest possible volume, which of course is connotatively so meant counterspace. We can say the ether, counterspace, vacuum energy, 0-point energy, all these pathetic little names that people love to apply to things and referring to one thing. But I mean, of course, nature does not give a damn what we choose to call it. Here we're looking at the top of a supercell and magnetic polarity. Here we're actually looking at both poles. I can tell over here, since it's brighter and the bowl-shaped formation is very clearly defined, that this is the south pole on the left and this is the north pole over here. Since we have due to geomagnetic precession, we actually have a phase variance, which is always a golden ratio proportionality, ratio of 1 to 5. Geomagnetic precession is the pressure mediation of magnetic polarity, which is of course three-dimensionally divergent. This accounts for all natural vortex phenomena. A single force vector is not merely spatially divergent, but also necessitatively so mutually curvilinear, and herein is the double vortex formation and the genesis of geomagnetic precession. Here we actually see a origami type formation showing a hyperboloid. However, it's a bit too blocky, of course. In reality, it's not blocky like this, but if we actually follow one of these lines, we'd actually have a three-dimensional force vector. You'd actually have to follow it around like this and around like this, so we actually have a three-dimensional force vector. This point right here at the center would be called a two-sheet hyperbola. So it would be actually a 0 point here rather than the shown breadth. So this is slightly inaccurate, but you get the point here. The incommensurability of a conjugate field in a magnet, that being the magnetodielectric object, has a presence relative to the binding object, which we call the magnet, but there is no actual Cartesian value that can be localized in the magnet relative to any aspect of the fields themselves. This is what Tesla meant when he said there's no energy in matter other than that which it receives from its environment, i.e. the ether, as meant and implied, of course. One cannot understand the field incommensurability of a magnet without grasping the magnetodielectric hyperboloid at a fundamental level within your mind. Inertia cannot be measured by means of mass calculations. This very premise is the basis for every flaw of relativity, quantum mathematical atomism, and non-Euclidean pseudophysics. There is no north pole or south pole in a magnet, and you cannot slice it and separate the two fields. The fields are pressure forced to their respective locations. There is no Cartesian value of polarity in a magnet, no location, no midpoint, no so-called block wall. It's just not there is meant, as the ancient Greek term implies, topos, meaning place or location. Here I actually have the superimposition of the conjugate magnetodielectric, the magnetic outlined in yellow, and the dielectric outlined in green. And of course we would superimpose a magnet in white over top of this. Here we can actually see a spiral arm galaxy. This This geomagnetic precession is the release of trillions of tons of the creation of the most fundamental element, hydrogen, from the point where there is nothing at the center. Here we have the unmanifest, non-Cartesian eject of a supermassive black hole. And of course, like I said, a black hole is neither black nor is it a hole. But, and of course the galaxy would be the plane of inertia right here. Once again, we have this same field geometry from macro to micro, and the same field geometry in the spiral arm galaxy is what we also see in the magnet. This is just showing two magnets actually being brought together, of course creating one magnet. So there is no pole that is localizable. It has no Cartesian value, and most people actually know this. Here we actually see the same side-on view of a galaxy, and the same hyperbola, the hourglass shape, due to the geomagnetic precession of the null point and the plane of inertia. And of course, we now know only recently, but it must be necessitated, that we actually have this huge, around every spiral arm galaxy, we have this huge magnetic torus actually encapsulating this formation, which of course is not visible, obviously so. There we go. Take a look at geomagnetic precession. Let me enlarge this a little bit, and you see a three-dimensional force vector on a torus here. There is no north pole and south pole in a magnet, since you cannot slice and separate out the two field. The field pressures, as I said, are forced to the respective location. If we actually go on to a laser analogy, this incommensurability is spatially coherent like a laser, and I'm going to use this laser analogy to point out the similarities of incommensurability and point nonspecific, and also point source. Spatially coherent light has another name. It's also referred to as sphere waves or plane waves, or even simpler, pinhole light or point source light. Coherent light is simple. It's light which comes from a very small light source. Light from a single source is always coherent, since the incoherence requires at least two different Cartesian sources. This is also the reason why LED light is so damaging to the eyes, is because all LEDs are essentially point sources of light. They are very damaging to human eyes. And since incoherence requires two sources by definition, the so-called lines of force seen in a magnet are merely the constructive and destructive interference patterns of the polarity, i.e. the two sources of the centrifugal divergence and centripetal convergence of the magnetism, against the dielectric. It can't even exist any other way. This is the very definition of the ancient Greek term anarche, translated as necessity, but what it actually means is it can't exist any other way. You're actually looking at geomagnetic precession here, which, by the way, the precession rate in average is 42.5 megahertz. Here we're looking at the hyperboloid. Now this is incorrect. And at the top we'd actually have a human line, and of course to make a line, in the case of a human line, we actually have to have an XY vector to actually hone in on a point, and then from that we draw a line. To make a line, we have to start from a point, and then we actually have to start with a line, then to make a point, and from that point make a line. And that's a human line. Of course, underneath that we'd actually have Mother Nature's line, which starts in a point in counter space. But of course it can't be like this, and this is a straight line. There are no straight lines in nature. This, of course, is still incorrect, but take a look at this. Since this is two-dimensional, at the bottom here we'd actually have Mother Nature's line. A magnet is like a laser in that it is a field multiplicative phenomena, wherein which point source emission is not additive but multiplicative in nature, or conventionally is meant power. A pre-magnet is quantitatively the same object with nearly infinite mutually destructive sources at the level of the atoms and the molecules themselves. Upon becoming a magnet, there is point source incommensurability within the conjugate fields of the magnet, which then creates the ab extra field phenomena around a magnet, which people think incorrectly is being emitted by the magnet. Rather, however, this ab extra field is, of course, the medium itself, i.e. the ether. In-phase emission causes the amplification of light in the case of the laser. It doesn't cause coherence of light in the laser. Because atoms emit the phase with incoming light, they will amplify the light, but they also amplify the incoherence additionally so as well. They do not make it coherent. The coherence of a laser light has another source. The two characteristics of laser light is it is monochromatic, meaning a very pure frequency. This is also called temporal coherence. Laser light also has a point source character of sphere waves or plane waves, also referred to as spatial coherence. Starlight, for example, has coherence in millions of kilometers, and starlight is far more coherent than any human-made laser. The most distant stars are just like ideal point sources. Interestingly enough, of course, our closest star, Betelgeuse, astronomer A. A. Michelson discovered that Betelgeuse is far, far less coherent than other stars. That's because it's so close to us. Let me take a look at this and enlarge it a little bit here. Dennis Gabber invented holography before lasers existed. To create his pseudo-lasers, he took light from an ordinary mercury arc lamp and passed it through a pinhole aperture. Mercury's emissions line made it nearly monochromatic, and the pinhole gave it spatial coherence. So we actually have monochromatic light pass through a pinhole to make it spatially coherent. Then we pass it through a wavelength filter, and this is how we were actually able to create holograms before lasers even existed. Specifically, Dennis Gabber did. I'm using this laser analogy to draw the parallels and give a representational analogy to the nature of the magnet when we're talking about spatial coherence here. People don't understand what actually defines a magnet. We'll, of course, define magnetism in section 6. In short, to make up a lecture, to fully describe it, would take many, many hours, and of course requires a book, which unfortunately I'm burdened with producing. Nobody's burdening me, however, I guess. In-phase emission causes the amplification of light. It doesn't cause the coherence of light. Because atoms generate light in phase with incoming light, they'll also amplify that light, but they amplify the incoherence as well, and they don't make it coherent. When a laser is first turned on, it fluoresces and emits light which is not coherent. Different random light waves start out from different parts of the laser. After a few thousand mirror bounces, all the light waves have added up and subtracted to form one single or point source EM emission. There we go. So what's the difference? We got a light bulb here on the left and a laser on the right. What's the difference between a 5-watt light bulb, which is useless for anything? Nobody makes... I think they do make 5-watt light bulbs for like little oddball purposes, but a 5-watt laser light bulb you can't even read by. 5-watt laser, however, is dangerous, powerful, it'll blind you, and it'll burn a hole in your ass. What's the difference? Well, coherence. No, you're partially correct, but what makes the difference is one is point source, the other one is not. A lot of things that people also don't understand about lasers. Let me read this final paragraph here. That most types of lasers actually emit spreading, non-parallel light. Lasers and CD players and laser pointers are semiconductor diode lasers. They create cone-shaped light beams, and if parallel beam is desired, which everybody thinks a laser is just this parallel beam or lightsaber of light, and that's not how lasers actually work. But if the parallel beam is desired, they require a focusing lens. The same is true for all lasers, in the case of like inexpensive laser pointers, and even in old glass tube helium neon lasers like this, which I used to have. If you actually take apart an old laser pointer, you'll find the plastic lens in front of the diode inside. Like the classroom helium neon lasers also create a spreading light beam. The laser tube within a typical classroom laser contains at least one curved mirror called a confocal arrangement, and it creates light in the form of a spreading cone. It's a little known fact that manufacturers of classroom lasers traditionally place a convex lens on the end of their laser tubes in order to shape the spreading light into a parallel beam. While it is true that a narrow beam is convenient, it's the case that most people, have the stereotype that all lasers produce these thin, narrow beams of light, and that's not the case. These lasers actually have confocal arrangements, and they have actually focusing lenses on them. Lasers do not create this narrow beam of light, as everybody conventionally conceives it to be the case. This is another example of point source light, and this is the case of magnetism as well, which is why I was discussing lasers, is that we're actually talking about point source emission. We actually have this incommensurability, this point non-specific point source incommensurability of the field, this conjugate magnetodielectric field of the magnet itself, but there's nothing located there. It is the pressure mediation necessitated of the energy emission and the magnetodielectric geometry of the torus and the hyperboloid mediating out their own pressures. Everything in nature, of course, is pressure mediation. This is topological spaces versus metric spaces, vector spaces, and counter space, which would be measured in negative numbers. Another type of representation of counter space. get into that too much, but I wanted to actually point this out and make the laser analogy to refer to the incommensurability of what is going on in a laser, in a magnet, excuse me, by using this laser analogy. And this, of course, was only two-dimensionally so, but the S-curve representation of Mother Nature's force vector. Of course, if we were to look at this in 3 dimensions, it would be an S-curve in 3 dimensions. And when you actually have an S-curve in 3 dimensions, and if you want to think about it, just think about one finger. And of course, human hands can only twist so many ways that if you actually take your hands like this and bring them together and you spread them apart like this, and you look at one finger and another finger on the other hand, you'd actually end up with, if you're able to mentally draw that, about the easiest analogy that I could think of to show you what a 3-dimensional force vector looks like. In the case of the magnetism, which actually begets geomagnetic precession, and of course geomagnetic precession, also called the Lamore frequency, is necessary to know for tuning a MRI machine, a magnetic resonance imaging machine, but you'd also have an understanding of what a 3-dimensional force vector is, and also to denotatively, what is a vortex? Not in description, but in definition. So take your hands like this, where you actually have them balled up like this, bring them together where you can actually spread them apart, and then unravel them like this, any mirror image of one another. If you actually take one line from one hand and trace it to the finger of another hand, you'd actually end up with the 3-dimensional force vector, if you want an easy way to imagine it in your mind. But this is the end of Section 5, and Section 6 will go into defining magnetism itself. And if you like these videos, please click the link below. Anything helps at any time, but I'm all about understanding and comprehension, and whatever I could do to help somebody else in that front, that is my pleasure. Thanks so much for watching, and check out Part 6.